Warahmatullahi wabarakatuh. I want to continue part B. So in previous class, I have actually discussed 3 example. Okay, start with this one, beam with one redundant. Beam with one redundant. Okay, under discussion in class ni, under your class notebook, please refer to discussion in class. So start with this one. Okay, and then this one, beam 2. Okay, beam 2. And just now, okay, we discussed this one, this beam. Okay, the first two beam, I have set BY as the redundant. BY as the redundant. So this time I want to change redundant to moment, because always remember that for one redundant beam we have two redundant option. We have two redundant options. So in this case we can actually remove either MA. We take out one moment from fixed support as the redundant, or we can also remove BY as the redundant. Okay, so this time I choose MA as the redundant. I choose MA as the redundant. So with this redundant, we should be able to write the compatibility equation. Okay, we should write the compatibility equation straight away. And the compatibility equation is actually based on the principle of superposition. Okay, where the general equation is actual structure equal to primary structure plus redundant structure. Actual structure is indeterminate structure. Primary structure is both determinate structure. Determinate structure. Determinate structure, both redundant and primary structure. Okay, we have compatibility equation. Compatibility equation will be based on the displacement. It can be delta, it can be theta, depending on the redundant. If BY is the redundant, we will have delta. Okay, delta at position B. This time, I want to choose MA, moment at A, as the redundant. So we will have theta A naught. Theta A naught plus FAA. So this will be the standard. This form will be the standard compatibility equation that you are going to use to analyze all type of structure. Okay, so this will be the standard form. The standard form, except the first notation will refer to the redundant position. When the redundant is located at A, this will be A. So it can be B, it can be C, it can be D, depending on the redundant position. Okay, and F also will be fixed. Fixed at this position. F is flexibility coefficient. F is referring to the rotation. Rotation if it is moment. F is refers to delta if redundant is force. Okay, so F, so fixed at this position. Okay, AA, so the first notation always refers to the position. A at both delta A, not A first notation, FAA also A first notation. The second notation is for type of beam. By looking at the second notation, we know that okay, this one, this is for primary beam. This is for redundant beam. So ada two sign for redundant beam. One is F. F is always referring to the redundant F. Okay, so this is the compatibility equation. And this F cannot stand alone. F we must pair with the redundant. FBB, if BY is redundant, it is FBB times BY. If CY is redundant, it is FCC times CY. If DY is redundant, it is FDD times DY. If MA as the redundant, it is FAA plus times MA. So this is actually the standard form of compatibility equation. And inside this, we have redundant. And we need to determine this redundant. Okay, this redundant in order to calculate the remaining 3 unknown reaction. Okay, so if we want to calculate MA, we have to calculate displacement first. Displacement in primary system. Displacement in primary system. Theta A naught displacement in primary system. FAA, it is in redundant system. Theta in redundant system. So what is theta A naught? What is FAA? So this is the formula we adopt, okay, from unit load method. Okay, theta A naught means MA times M naught. FAA means MA times MA. MA times MA. So from this, we know that we have two systems. One is primary system and second one is redundant system. One is primary system. Here, one is primary system. Another one is redundant system. Primary, we always use the symbol not. Okay, redundant system. So we will have moment equation which is come from primary structure or primary beam. And the moment equation for primary beam is M naught. Okay, M naught. Naught is always for symbol for primary structure. Redundant structure, this is M. Moment equation, small letter, moment equation. So this M, okay, if the redundant is moment at A, so we can put this as MA. Not moment at A, but this is moment equation for redundant MA applied. Okay, so we have this. So in order to solve MA, the capital one, moment at A, we have to calculate two displacement which come from two systems using these two formula. And inside this formula, there are two moment equation. One is MA, one is M naught. MA and M naught. So these two systems, okay, refers to this. One is primary structure, primary beam. One is redundant structure, redundant beam. In primary structure, we have to remove redundant. So original at A is fixed. But after removing redundant, the fixed become pin. After removing redundant, fixed become pin. Okay, kalau pin, you want to remove another one, you have to remove horizontal force, horizontal reaction, so that it become roller. So from fixed to pin, from pin to roller. Okay, from fixed to pin, from pin to roller. Okay, now we want to remove only one, so we have to remove moment. Okay, so when we remove moment, the fixed become pin. So we have determinate beam. A, we have to change to pin support. And we remain B. Roller support at B, we remain. Okay, so this is B, this is C. Okay, so in primary structure, in primary beam, after we remove moment, it become simply supported beam. Okay, with one cantilever end at C, loading 40 kilonewton remain. Because the only thing that we remove from the actual beam is the moment at A. The moment at A. That is primary structure, primary beam. Okay, we move to the second one. The second one is redundant structure. Redundant structure. Redundant structure is same type of beam. You just need to follow the same beam except loading. Sama je, support dia sama, ada A, ada B, ada C. Okay, A dekat pin, dekat pin ada, dekat A ada pin, dekat B remain roller. So it is the same beam. Primary beam and redundant beam both are the same except loading. Loading. So primary system, in primary system, it is a determinate beam subjected to external loading. Subjected to external loading. Redundant system, redundant beam, it is the same beam subjected to a unit moment. Because redundant is moment, so subjected to a unit moment. A unit moment. So this is moment. We apply moment. We apply moment at A as an applied moment, not as fixed support, but we apply a unit moment. Okay, a unit value of MA. Okay, we divide 1 times MA because we want to analyze due to a unit value. So there are two systems. Okay, one is primary system and another one is redundant system. So having this two system, now we have to, number one, calculate reaction. Number two, using the reaction, we calculate or we write moment equation. Number three, based on the moment equation, we calculate displacement. And this displacement, we substitute into this formula, the moment equation. So the moment equation for primary beam is called as M naught. The moment equation for redundant system is called as MA, MB, MC, MD, depending on the redundant. Okay, now we will continue to calculate reaction. I want you to calculate reaction. Okay, please calculate reaction. Now, AY and BY for both. Because AX is 0. So please calculate for me. AY, BY. Please calculate AY, BY for both systems. Please calculate. Right now, about 5 minutes, please calculate the reaction for primary system and redundant system. Can you please do that right now? About 5 minutes. Okay, please calculate right now. I want you to upload your you need to snap your calculation, the reaction, and upload in Teams here. You can upload in okay, boleh upload in your private group. Or you can also upload in the chat. Okay, the conversation box. Boleh upload kat sini juga Okay, like what your previous my previous group did this morning. Okay, like this. Can anybody? Ataupun nak cepat terus calculate and give me the answer. Okay, give me the value for AY and BY for primary beam reaction due to 40 kilonewton subjected at C. So what is AY? What is BY? Ada tak anybody yang calculate AY and BY? Okay, please help me to calculate the reaction. Berapa the reaction at A and B for both diagram?
Kalau AY saya dapat negatif 40, BY saya dapat 80.
Okay, AY negatif 40 ya. Negatif 40. Ini dapat 80. Okay, so for redundant structure, AY and BY for redundant structure. This is primary beam. Cepat, ramai lagi dalam kelas ni. Please calculate redundant MA applied. Cepat-cepat, I'm waiting. Due to a unit moment at A, what is AY, what is BY?
Saya dapat kosong.
Kosong? Is it kosong? AY and BY. This is just the simple calculation, right? 1. Kalau taking moment at B, dapat apa? Taking moment at B, we get 1 plus AY times 2. Taking moment at B, 1. Kan AY kat sini. AY. So it is 1 plus kan? Plus AY times 2 equal to 0. So AY equal to
1/2.
0.5.
negative or positive?
Negatif.
Negative.
Negative.
Negative 0.5. Negative 0.5. So BY is is positive 0.5. Okay? We get 0.5 negative and 0.5 positive. This is A. Okay? So reaction is compulsory. Reaction is compulsory. Kan the step to the knowledge that you learned previously under solid mechanics. Start with reaction. Okay? And after that moment equation, we write moment equation after we calculate reaction. So in order to write moment equation, M0 and MA, so we must have reaction. So that is why we do this step. And reaction, we have to have reaction in two systems. One is primary system, one is redundant system. So we have to calculate for both system. Okay, so we have AB and BC. So we have two cutting section. We have two cutting section. We have section AB for the first cutting section, and we have BC for the second cutting section, and remain the same cutting section for both. Okay, remain the first cutting section for both. So next step is moment equation. Moment equation. In structural analysis, I have mentioned in the first week or second week, I have mentioned. Okay, in structural analysis, in short, we can summarize the structural analysis in these three terms, three words: reaction, calculating reaction, internal forces, and displacement. So when we analyze indeterminate structure using flexibility method, we have to apply all these three process. Start with reaction, internal forces, and displacement. Then only we can calculate the redundant. Without these three, we cannot calculate the redundant. Without redundant, we cannot solve the problem, the indeterminate structure problem using flexibility method. Okay, so start with reaction. Why we calculate reaction? Because we want to write moment equation. Moment is internal forces in beam in frame. Without reaction, how are we going to write moment equation? Okay, and moment equation is needed to calculate displacement. Without moment equation, we cannot calculate displacement. So we must follow this step. Okay, we must follow this step in flexibility method. Okay, and we have to do 2 times because we have two systems, primary system and redundant system. So for both system, okay, it has the same type of beam, same type of support, same section, same origin, same limit. The difference is only due to loading, because in primary structure, it is a determinate structure subjected to external loading, just like real system. Okay, and in redundant structure, it is a determinate structure subjected to a unit value. Okay, so this time, this one is redundant MA applied. So it is a unit moment at A. Okay, so with this, we have to calculate reaction, and after that, we have to write moment equation. Okay, since we have more than one cutting section, okay, I normally summarize the moment equation in table form, because after this, we may have 2, 3, 4 cutting section. So we summarize the moment equation in table form. Member, Okay, one column for member. We have member AB, we have member BC, and we have to choose origin where X started. Okay, X, because in cutting section, we have to choose origin. X will be equal to 0 at origin. And then the length, limit of X from 0 to 2. In this case, 0 to 2, limit. And then we have to add another 2 column, one for primary system and one for redundant system. So there are two moment equation. This MA, sorry, M not first, primary dulu. So primary, okay, this is primary moment equation for primary system. We know that this is primary because the symbol not that we use. Okay, and MA, this one can be changed to M1, okay, for the standard form later on. Okay, try to understand this one first. Where is the cursor? M0 and MA. So one is for redundant, one is for primary system. One is for redundant, one is for primary system. Okay, so we have two cutting section. We have AB and we have BC. We have to list all cutting section. Okay, we have AB, origin A. For AB means that X start from A, and we have cutting cutting section number 2, BC, and origin is C. Okay, so choose the shortest section. So when we choose C as origin for section BC, it is the shortest. Okay, so for the limit at X at origin X is equal to 0, at B X is equal to 2. Okay, for BC, this one you have to refresh back. All this I believe you have learned in solid mechanic how you write the moment equation. Okay, the limit of BC at origin X is 0, at C at B is 2. Okay, so this is the limit. It will change if you change the origin. Limit will be depending on origin. If you choose A as origin, so of course this will change to 2 to 4. Okay, since I choose C as origin, so I will use 0 to 2. Okay, now we will write the moment equation. So look at the diagram. Okay, the moment equation, origin A means M rotate this direction. Okay, C as origin, moment rotates clockwise. Okay, for the moment equation. So what is M0 for AB? M0 for AB. This part. M0 for AB. M0 for AB, this is 40. This is moment. M0. So what is M0? What is M0? This is X. X. So this is M0. So what is M0 for this cutting section? Cepat. What is M naught?
40 multiplied by X.
It is negative or positive?
Positive.
Is it positive?
Negative.
Negative. It is negative 40x. It is negative 40x. Negative 40x. Okay. Move to BC origin C. What is the equation? It is like this, 40. Rotation like this, moment rotate like this. So this is M naught. So M naught is equal to, this is X. What is the equation? What is the equation?
40 multiplied by X.
40x. Negative or positive?
Positive.
Is it positive? Is it positive? It is M naught plus 40x equal to 0. For negative or positive?
Negative.
Negative. Negative 40x. Negative 40x. This. Okay. So now refer to redundant system. Redundant system, we have MA for AB. For AB, so what is the equation? The diagram look like this. Negative kan, 0.5 moment like this. This is MA, moment equation. Okay, X. So what about this, MA? What is the equation for moment equation? This moment equation. What is the equation?
Negative 0.5x, negative 1.
Negative 0.5x, positive 1 or negative 1?
Positive 1.
Positive.
Okay. 1. It is 1 minus 0.5x. Okay. So, last one. BC origin C. What is the equation? BC origin C. What is the equation? What is the equation? It is, adakah equation?
Tak ada, madam.
Tak ada. Okay. So this is the table. Okay. We put all the moment equation in one table. Yang ni saya bawa ke tepi. Nanti yang ni semua you boleh refer balik. Okay, saya letak kat tepi ni. Okay, if you want to refer. Okay, now we want to continue to calculate displacement. Displacement theta A0 and FAA. So these are the two displacement in primary system and in redundant system that we need to calculate. Okay, this. Okay, so we have to integrate moment equation. We have to integrate moment equation. So we have theta A naught means that MA and M naught. Theta A naught is MA and M naught. FAA means MA times MA. Okay, so integrate using calculator. Do not integrate manually. Do not integrate manually because you will spend more time to do that. But what most important is we want the displacement, because if we don't get displacement, we don't get redundant. Okay, so please right now integrate theta A naught and FAA. Actually, you don't have to rewrite all the equation again. We have, because you have put into the table. But for this time, because this is the first time, so doesn't matter. I just put in full 0 to 2. 0 to 2, it is MA M naught. MA M naught is 1 minus 0.5x times with negative 40x dx. Okay, that is for cutting section number 1. Okay, we have to plus with another cutting section. Plus with another one. Where is another one? Okay. 1 over EI. EI. Okay, from 0 to 2 for BC ini. 0 to 2. Okay, this is 0 times negative 40. So, tak tulis pun tak apalah. Because it is 0, so we get 0. So, this one. Okay, what is the answer for this? What is the answer for this? Okay, use calculator, calculate this. What is the answer? We integrate 1 minus 0.5 x and negative 40 from 0 to 2. We integrate 1 minus 0.5 x times with negative 40 x. Limit is 0 to 2. So what is the answer? Negative 26.667. What do you get?
Same.
Sama? Same
Sama.
answer?
Madam.
Sama
Yes, madam.
Okay. Negative ya tadi. So it is 26.667. Sini EI. Sini negative. Okay. Okay, what about FAA? FAA. FAA is 1 over EI integrate from 0 to 2. Okay, we refers to MA. It is 1 minus 0.5x square. One minus 0.5 x square dx. So what is the answer? So what is the answer for this?
Then saya dapat 0.6667.
0.667, negative or positive?
Positive.
Positif.
Positive. Okay, wait. I check first. Everyone, yang lain-lain dapat apa?
Sama, doktor.
Sama, madam.
Sama, doktor.
Okay. So it is, yes, 0.667. 0.667 divided by EI. Okay, so now we get the two displacement, theta A naught and FAA. So what we need to do after this? What we need to do after this? Substitute, yeah? Substitute into compatibility equation. What is the compatibility equation? What is the compatibility equation? Theta, it is theta, mana dia? Original equation. Okay, this one. Okay, theta A naught plus FAA. Okay, this is the equation. So we just need to substitute. Okay, this. Negative. Okay, plus with this. Okay, don't forget, for redundant, we must always, for redundant system, all the value in redundant system, displacement or reaction, we must times with redundant, MA. Okay, we must times with redundant, this. So this is equal to 0. So solve this, what do you get? Okay, solve this, what do you get? MA MA is equal to 26.667, right? Divide by 0.667. So the answer is, what is the answer? The moment at A. Okay, what is the answer? 26.667 divided by 0.667.
39.98.
39.98. Correct. Okay, 39.98 unit kilo Newton meter.
Meter.
Okay, because it is moment. Because it is moment. Okay, so having this redundant, can we calculate the remaining? Calculate reaction using equilibrium equation. Can you calculate the remaining using equilibrium equation? AY, AX, and BY. Can you? Boleh kan? So what you need to do is
Boleh.
you just need to draw the diagram. Draw the diagram. Okay, this is AY, this is AX. AX, this is BY. This is 40. And moment is 39.98. 2 meter, 2 meter. Okay, so continue to calculate remaining 3 unknown reaction using equilibrium equation. Okay, I believe everyone should know how to calculate the remaining reaction. Betul tak? Semua orang boleh calculate remaining reaction?
Boleh, Doktor.
Doktor.
Okay, we have another option. Siapa tahu? What is another option to calculate 3 remaining reaction? By using principle of superposition. Superposition, and this will be easier than the equilibrium equation. Okay, so we have 3 remaining reaction. We have AY, we have AY, we have MA, AY, AX, and BY. The remaining 3. We have A, we have AY, ini AY. Okay, look at AY. Okay, we are referring now to principle of superposition. Principle of superposition, this equation, general equation, actual structure, we are now calculating reaction in actual structure. And we have actually calculated reaction in primary structure and in redundant structure. So by using principle of superposition, what we need to do is we just need to plus primary structure plus redundant structure, we get the reaction in actual structure. But don't forget, in redundant structure, everything must times with the redundant. Okay, so refer back to this diagram. We have AY in primary structure. We have AY in redundant structure. Okay, by using principle of superposition, by using principle of superposition, okay, we have to plus this primary beam plus redundant beam. And remember, as I mentioned, FAA cannot stand alone. We must time with redundant, remember? Okay, reaction in redundant system also we need to times with redundant. Redundant 39.98. 39.98 the moment that we have just determined. Okay, so to get the reaction AY, so we can get AY by using this equation. It is negative 40. Just follow this, the formula, the general equation. Negative 40 plus negative 40, let me highlight. Negative 40 plus negative 0.5 times 39.98. Do you get what I mean? We use the principle of superposition, primary beam, where primary beam plus redundant beam equal to actual beam. So in order to calculate remaining reaction in actual beam, we just need to use principle of superposition to get the remaining reaction. So actually we have two options. Not only we solve the remaining reaction using equilibrium equation, but we can have another option. Okay, it is by using principle of superposition. So what is AY? What is AY? Negative 40 plus negative 0.5 ya? Negative 0.5 kan? 0.5 times the redundant. The redundant is 39.98 and it is equal to, okay, nampak tak? Okay, this is the easiest compared to, okay, if we compare to equilibrium equation, this will be easier lah. Okay, so what is the answer?
Negative 1619.19.
Negative
1619.19.
Kejap. So again. The rest, what about the rest?
I get 59.99 negative.
59.99. Okay. Check balik yang tadi tu. Check balik. So it is negative 40 minus 0.5 MA. Negative 40 minus 0.5 MA. We should get negative 59.99. Okay, thanks for responding. Tak apa, just check balik. Okay, what about BY? What about BY? What about BY? Why?
99.99.
Okay, it is 80. Okay, it is 80. So this one is 80. And then plus. This is plus 0.5. Okay, times 39.99. Mana lagi simple? Using superposition or equilibrium equation? Mana lagi simple? What is the answer?
Superposition.
Superposition.
99.99.
Yes, 99.99. actually you can use principle of superposition to complete the analysis to get all the reaction for unknown reaction, and you can use equilibrium equation for checking. Okay, you can use equilibrium equation for checking. Okay, so AX is equal to 0. So you have two options. Either you want to use equilibrium equation to calculate three remaining reaction, or it will be more easier if we use principle of superposition to calculate remaining reaction. So my suggestion is use principle of superposition to calculate remaining reaction like we have done just now, and check. Okay, check the answer by using equilibrium equation. Means once you have calculate all the reaction, put into diagram. Okay, put into diagram and taking moment. Okay, taking moment at A, check whether you get 0. Taking what? Fx, total Fx is equal to 0. Total Fx, total Fy is equal to 0. Check whether you get all in equilibrium condition. So By we get 100 sini. Okay, Ay we get negative 60. Betul kan? So we get total Fx is equal to 0. Okay, so we just need to check lah. Normally tak perlu check pun dalam test, dalam exam tak perlu check. You just need to complete the 4 unknown reaction. Okay, so this is how we analyze, and we will repeat the same. We will repeat the same process for all type of structure. Okay, start with calculate, identify redundant, choose redundant, remove redundant. Okay, write the compatibility equation depending on the redundant that we have chosen. Okay, and from the compatibility equation, we know that for one redundant, we know that there are two displacement, and we have to get the two displacement come from two system, primary and redundant system. Okay, so we have to analyze two determinate system, two determinate beam, same support, same section, same limit, same origin, except loading is different, because primary beam we have to remain external loading, and redundant beam we have to remove all the external loading, we need to remove, and it is just subjected to a unit value of redundant. So for both system, we have to calculate reaction and write the moment equation for beam and frame. Okay, so I summarize into table like this, and I calculate we calculate the displacement. Okay, so yang ni semua actually if you want to skip, you just need to put the answer, doesn't matter, because you have written the equation in the table. Okay, if you want to write also can. And then so these two displacement substitute into the compatibility equation, and by solving the compatibility equation, you will get the redundant. So once you get the redundant, we can solve remaining reaction. Okay, using either equilibrium equation, or it will be more easier if we use principle of superposition to calculate the remaining reaction, and just use equilibrium equation for checking. Okay, so this is the whole analysis. Okay, we have determined the final aim. So remember, flexibility method is also called as force method. So reaction is force. And actually you can continue to draw diagram, of course, shear force diagram and bending moment diagram once you have the reaction. Okay, so this is actually the procedure to analyze structure, beam and frame Okay, frame will be similar. Okay, using flexibility method. So this is the basic one lah. The basic one, because we will also need to consider the effect. Okay, normally for beam we will consider the support settlement effect. Support settlement effect, beam and frame, and another effect called temperature changes and fabrication error. We will use N, yeah, we use N. Okay, for temperature changes and fabrication error, we will analyze in truss. Okay, and member forces in truss is N. Member forces in beam and frame is moment equation M. Okay, so I want to summarize all this. So nanti you tengok balik video yang I have actually discussed in these two group. Okay, I want to summarize all this. Because we want to have compatibility equation in general form. We want to have compatibility equation in general form. So the compatibility equation in general form is actually written. Okay, I want to write the compatibility equation. Compatibility equation in general form, which we can write, okay, based on numbering. One redundant means we will have R1. Two redundant, we will have R1 and R2, because next session we will discuss on two redundant system. Okay, so for two redundant system, it is best to change the ABC symbol to numbering. Okay, to numbering. So now we analyze one redundant. So redundant, the general form of redundant. Okay, we can change to R1 for the general form of redundant and R2 for second redundant. So I will take this. Okay, what I mean is like this. Ini summary, ya. Ini summary. Okay. Redundant. After we choose DOI, we choose redundant. After we calculate DOI, we choose redundant. Redundant. Okay, redundant. Redundant 1. Redundant 1. Okay. Redundant in this case is redundant number 1. Okay, redundant 1. Redundant 1. Okay, redundant is redundant number 1, R1, which is equal to MA. So to be general form, okay, to have the general form, we will translate the A symbol to 1. Semua A tukar jadi 1. Means that yang mana ada A dalam compatibility equation ni, we will change to 1. So, R1 is MA. So, A will change to 1. So, theta A naught will become, okay, A1 naught. FAA, because A tadi kat sini, sini pun A sebab depan sini A. Okay, so yang ni akan tukar jadi 1 juga. Semua A we change to 1. So FAA will be FAA. So this will be 1, 1. Because theta 1 naught, it will become F11. Theta A naught, it will become FAA. Theta B naught, it will become FBB. Now we want to move to the standard form. Standard form, it is theta 1 naught plus F11, okay, times MA. Times MA. Okay, MA is R1. Okay, if the redundant is BY, if redundant is BY, for example, is redundant is BY. If redundant is BY, for example, this is B, this is Y. Okay, so what happened to the equation? We get, wait, I copy from the previous. Bukan ini. Yes. So the general form of compatibility equation. Okay, now the symbol is B. So all B will change to 1 including the notation that we use, delta B naught, we change to 1 naught. 1 naught. Okay, sini. Okay, B change to 1, BB change to 1, 1. Okay, times redundant. Okay, so we will use 1 not 1 1. Okay, to be more general. Okay. And to be okay, this is still specific to MA, specific to BY. So in order to apply to all type of question, where the redundant can be located at anywhere, okay, at anywhere according to the support. Okay, so we can have one general form of compatibility equation which is written as this, R1. Okay, so this will be the general equation that can be applied to all questions. Anyway, I will prefer to use this one or this one, because if we use R, we do not know whether it is moment or it is force. So I suggest you to use the standard form, but remain the redundant as the redundant name, not the general form, the R1. So if the redundant is MA, put MA as the redundant in the equation. If redundant is BY, put BY. So we just change the symbol to 1 naught and 1 1. Okay, so if delta we use delta 1 naught, so what happened to the equation? So we will have M naught and M1 come from redundant primary system and redundant system. For example, if we have this, okay, if we have this one, right? Okay, this is actual. Actual is equal to primary system. Okay, actual is equal to primary system plus redundant. Ini yang tadi. Redundant, a unit moment. Okay, so the moment equation for primary beam, because the equation we use theta 1 naught, means that we will have to integrate M1 and M naught. We always refer to the notation that we use. So M1, M naught, so means that M naught is the primary system M1 is redundant system. Okay, so for F11 means that it is 1 over EI. From 0 to L, it is M1 square dx. Means that after this, we will change into numbering. So M will be M0 for primary system, M1 for redundant number 1, M2 for redundant number 2, M3 for redundant number 3. So that we don't get confused. Okay. So nanti masa next session, next example, we will use numbering. Okay. When we solve the problem. Okay. Solve the beam or frame problem. Okay. Okay, anyway, if you want to stick to ABC, doesn't matter for one redundant. I just need to explain about this because when we move to two redundant system, it is best for us to use numbering. Okay, numbering one and two. One for redundant 1, 2 for redundant 2. Anyway, for one redundant, you can remain use symbol ABC. Okay, so now is 6:19, so I think we can stop this session right now. Okay, I hope we can have many session after this. Okay, to look at the many example exercises. Okay, and I welcome you to do this one. Okay, this question and submit in your OneNote class notebook so that I can check your understanding. Okay, I need to check your understanding because for me understanding is very important. Flexibility method ni, if you understand the aim, you understand the backward step that I mentioned, and inshallah I believe everyone can do. So what you need to highlight is the basic on how you write moment equation, write reaction, okay, including member forces in thrust. That is very important. Okay, so if you have any question to ask, you can ask me directly. Okay, I have actually, I want to show to you, I have actually created the private group under Teams. Yang ni, nanti saya completekan. Now we have group C, group E and group F. Okay, and actually I don't finish invite you into this private group. So if you have anything to ask and you don't want to ask in general channel, you can ask in private channel. Yang ni I will add you based on the registration list. Okay, so if you want to submit anything, ask anything, okay, discuss in group, you just put here and your friend also can respond. If, for example, if A put the question, so B can respond, C also respond, also can respond. I can monitor. Okay, if I need to comment, I will comment. Okay, so I think that's all for today's session. Thank you for joining. Inshallah, we will have another session to cover the derivation of compatibility equation for two redundant. For two redundant, I plan to have do you prefer Teams session or YouTube live streaming also okay? Which one do you prefer? For the next session, I will combine all four groups into one session. So do you prefer Teams meeting like this, or is it okay if I just I plan to do live streaming using YouTube, StreamYard. Which one do you prefer?
I prefer Teams, doctor.
Okay. So we will set the next session. Okay. Sorry for because I need to do in weekend because we missed 3-hour session in the first week. And start next week for the following 2 weeks, we will focus on the other type of structure. So we need to cover the derivation of compatibility equation by this week. Okay, so inshallah by this Saturday, is it okay 11 to 1 afternoon or you want night session? Which one do you prefer?
Afternoon,
I
doctor.
prefer afternoon.
Afternoon, doctor.
Okay. Okay, so we inshallah we will set the session at 11 at 11 to 1, okay, using Teams meeting. Okay, so thank you very much. Thank you all. I hope you will spend some time to watch the recording, to watch the recording. Okay, and please try to do exercises. Try to do exercises for your formative assessment, and please upload using OneNote. OneNote tu you pernah guna tak? Pernah upload tak? The OneNote. Do you know how?
Pernah ada.
Pernah kan? Okay, so just upload into the OneNote class notebook and okay, I will check for you lah your answer. Okay.